Um, Hello, welcome to my YouTube channel. And every week I'm going to talk about the summary of the semiconductor fabrication lessons. So, in the previous class, we talked about some hydrogen molecules, valence band, conduction band, energy gap, and some solid crystalline structures. So, we're going to first look at the hydrogen molecule. Um, This is the most simple model of the hydrogen molecule. As you can see here, we have a blue line, blue curve, and some horizontal black line. The blue line indicates the potential energy of the molecule, and the horizontal line indicates the eigenvalue. So, to make some easy points, by the Schrödinger equation, the energy gap gets fixed by the Schrödinger equation. So each energy gets fixed by the quantum number. Let's have a look at the E1 point. From E1 point, if the electron wants to jump up to E2 point, it needs any optical energy or some thermal energy to jump up to the next energy level. And I indicated with the purple color. In the purple color, no electron can be located between this gap. Now we are going to have a look with some 3 hydrogen molecules bonded together. Before we looked at the one hydrogen molecule, but now we are going to look with the 3 hydrogen molecule. If 3 hydrogen molecule bonds together, the lowest energy level gets stacked from the lowest point. So let's have a look at it. Because hydrogen has 1 electron from the outer space, if 3 hydrogen molecules bond together, there will be 3 electrons. So from the first orbiter, there is upstate and downstate. And the second point, we have only upstate. And the last, of course, there is no state. So this is when they are bond together, they form these curves. And the x-axis indicates the distance between the atoms, and the y-axis indicates the energy. Let's have a look at the lithium atoms. Also, in the outer space, they have only 3 electrons. It has the same state with the 3 hydrogen atoms bonded together. But now we are going to see with the n amount of lithium atoms. There is n amount of lithium atoms. Every state split it to n amounts, which means the n amounts gets divided here. So there will be 2 electrons, and some point in the green line there will be no electron. From here we can see, I'm going to talk with the next slide, but to give you a small clue, this will be the valence band, and here will be the conduction band. If there is infinity amount of energy level, they get splitted. I can just show you here. They will be splitted like this, and if there is a lot of amount of electrons, it may look like some energy band. So this is the introduction of conduction and valence band and the band gap. So here is the valence band. I told you in the previous slide, this point will be the valence band, and here will be the conduction band where there is no electrons. So to give you a definition with the valence band means at 0 Kelvin, it will be packed with the electrons, and the conduction band also in the 0 Kelvin, there will be no electrons. Between conduction band and valence band, it is called the forbidden band because no electrons can exist in this point. From the valence band to the vacuum energy level, it is called the ionization energy, and from conduction band to the vacuum energy level, it is called the electron affinity. Now we're going to have a look with some the difference between insulator, semiconductor, and metal. Insulator has the largest forbidden band because it insulates some materials. Some electrons will be hard to jump up to the conduction band if they get any thermal energy or optical light. But let's have a look at the metal. Valence band can be over the conduction band or very near to the conduction band. If they get a little amount of optical or thermal energy, it will be very easy to jump up to the conduction band. So we call this metal or conductor. And between them we have semiconductor, which is between metal and insulator. So if there is large amount of electron in the conduction band like metal, it means it is already packed with electrons in the valence band. Now lastly, we are going to look about the crystalline state of solids. There are three state of solids, which is crystalline, polycrystalline, and amorphous. In the crystalline, every grains are formed sophisticatedly, so there is no defect. And let's have a look at the polycrystalline. It is less sophisticated than crystalline. In amorphous, the grains have no any regular forms. So I think this is the most important part. Let's have a look at the grains of A and B. I want to give you a question. Which one will have the better mobility? Let's think of a huddle game. In the huddle game, if there are many huddles, it is hard to get your own speed. The speed gets lower if you meet any huddles. So it is the same with the molecules. If the grains are very small, if the electrons move to this point, every second they move, they will meet some huddles. So the speed will get less. Let's have a look at the B. At the same time the electrons run, and they will meet the huddles more or less than the A molecules. So if the mobility is good by the equation, the Ohm's law, J equals to Q and mu E. The mu indicates the mobility. So if the mobility gets better, the electron density will be higher. So from how we know the velocity by the mobility, from the equation, the velocity equals to mu E. So if the mobility gets higher, the velocity will be higher.